I want to go over a few points. I was working yesterday on my theory book on the circuit, the free energy circuit I've developed, the simulation of it. Anyway, and thank you very much for anybody who keeps saying like a mantra over and over again, build it. When are you going to build it? Thank you for saying it. I won't say anything else. So I was spending yesterday adding more material to the theory book. Now the theory book is an ebook with a lot of links because I reference Eric Dollard, among other sources. So I was watching over again for the umpteenth time his History of Electricity, History of the Theory of Electricity, I think it's called. Aaron Murakami puts it up on his YouTube channel. I had already watched and referenced, made use of the other presentation, the very long presentation of Eric on the origins of the synthesis of electricity, or the origins of electrical synthesis. I forget exactly the name of the title. That's also another good long piece of 4 hours with a lot of good material there. But the one on the history of electricity, on the theory of electricity, that was only, I think, 3.5 hours. And I didn't watch the whole thing, but I got a lot out of it watching about 2/3. And one of the things that struck me was the possibility, or the probability, that my circuit simulation is doing what Tesla's magnifying transmitter did. Now Eric says over and over again in this history presentation, several times, he mentions that caps and coils, capacitors and inductors, can do what Tesla's magnifying transmitter does without having to use a big Tesla coil to do it. Namely, it's possible to create a circuit to become a monopolar device. And normally every circuit is not it's not an open circuit, it's a closed circuit, so it always has a polarity of structure. And for instance, there's the source and there's the load. But I was reading on one, I think it might have been a Wikipedia article, in which the load becomes the source. Oh, it was very hard to find this reference, but I was able to find it. I was pretty certain what my circuit is creating is a -0 power factor. In other words, if we look at phase shifting between current and voltage, the 4 different options, there's only 3. There's 90 degrees out of phase, which is power factor of 0. There's everything in sync, and then there's 180 degrees out of phase. Well, it turns out there is such an animal called -0 power factor, or negative power factor. If it's -0, then it's totally 180 degrees out of phase, the current and the voltage. And it does exist. And what it means is the capacitive reactance is dominating when the power factor goes negative. And if it's -0 power factor, that means it's exclusively reactive capacitance without any reactive inductance. Now, this is practically a giveaway to what Eric has told us, that all you need are caps and coils. Well, I got my training in the beginning in the simulator environment using Eric Dollard's analog computer in LMD mode. That's longitudinal magnetodielectric, in which the capacitors are in series and the inductors are in parallel. And I would daisy chain them, or else I would just use one module, or else I would turn the module back on itself, so I only needed one module. And I did a variation of his. I don't short out the daisy chain between the coil linkages between adjoining daisy chains. I keep them separate. So each module is isolated by way of a transformer. I use a transformer to supply the iron core choke coil, so to speak. And originally I only would use one coil of each transformer, so I would use 2 different transformers. But then I realized, well, why don't I just put them together and loop it around and use one transformer? And it lowered the power gain, but it it helped resonance. It helped the stability of resonance, because now I had the phase relation of each coil more likely to be in sync, so it improved performance overall. You know, you want stability of resonance. You don't want it to be shaky, you know, subject to easily you lose your resonance and everything goes flat and you don't have over unity anymore. So this is the definition of negative zero power factor, is total exclusive capacitive reactance. And it's the best kind of reactance because it's the easiest to create over unity. Inductive reactance is a little harder. It can be done, it's just a little harder, as Peter Lindemann found out when he made an inductive device that was slightly over unity. But it wasn't consistent, so he wasn't too happy with it. But that was some time ago. Anyway, so in my device though, I've kind of, at some point in my training on the simulator over the past 2-3 years, I eventually graduated out of the use of Eric's analog computer. I didn't need it. Now, eventually I read his resource text on network analogs. He keeps citing Bewley, B-E-W-L-E-Y. Finally, I read the book, and well, I didn't read it. I'm not an engineer. I just went through and looked at all the schematics of networks. You know, Bewley lists different types of networks, and I realized I could create a circuit simulation of a derivative of one of his networks, and it proved to be fatal in the sense that it was too good. It was too explosive. It created over unity too quickly, and it was difficult to manage, so it's not practical. I can't use it, but it's extremely powerful. If you want something explosive, that's the way to go. And I'll tell you what it is. It's a ring of 4 capacitors. That's the inner ring. And then you have an outer ring in parallel to the inner ring of at least 2 inductors, if not 4. You don't need 4, but it might enhance it. I can't remember. But the inner ring has to be 4 capacitors, a square arrangement of 4 capacitors. And this is not quite Eric Dollard's LMD analog computer, but it's similar. Because the reason why you need 4 capacitors is that you only need 2. I forget which ones, the ones that are, well, it's probably the ones that are in series, in order to initiate the spark of over unity, so to speak, you know, the escalation, the logarithmic escalation. But then you can divest yourself. That's it. You don't need capacitors in parallel. No, that's it. No, excuse me. The capacitors in parallel help, the ones that are in parallel, the ones that are alongside the 2 minimum inductors, they help initiate the surge. But then you can take them out if you want, and just keep the ones that are in series to help, and that helps sustain the growth of the surge once it gets started. But you can keep in all 4, but it's just very explosive, so it's not practical. So I had to turn my attention to other things, and I came upon the shorted motor, similar to Jim Murray's transforming generator when it is shorted, except mine is not a transforming generator, but it is a motorized transformer, so it's kind of in the same ballpark, and it is shorted, so it's his transforming generator is a good similarity in the sense of what at least it's attempting to do, and generally how it's trying to do it. But mine is a little different. See, Jim Murray had certain issues that he didn't solve, and I solved them without even trying to. So I don't have the problems that he had. Let's see if I can remember what the problem was that he had. Well, it was uncontrollable. When it was under light load, its escalation to infinite gain was not controllable, and the thing would destroy itself. So he thought he could control it with switching, but I came up with a better method. I initially tried out switching, but I found there was a better way. Basically, I learned not to turn it off. You know, one thing about a surging circuit is you don't want to turn it off, because then it gets worse. Because the source acts as a voltage regulator. That's the main reason why I don't use much voltage input, because if I did, it would suppress the initiation and development of a transient. So in order to nurse a transient into existence, I use a high frequency but extremely low voltage around the microvolt range. And that way I don't suppress the transient by way of its regulation, because you know, when you feed an AC sine wave, that's a perfectly good way to reduce the likelihood of a transient occurring. DC is not such a good insurance. You know, Edison was plagued 100 years ago with transients on his line until Steinmetz figured out what to do about it. But Tesla's AC system is less prone to transients. It's not totally immune, but it's less prone because the nature of the AC wave is like a conductor in an orchestra. It helps regulate the activity and behavior of the waveforms along the transmission line such that it's less likely to become a transient and blow up in your face. But what that means is, if you have to reduce the voltage, and I reduce it to the realm of microvolts, similar to what a crystal radio set will pick up by its tiny little whip antennas, usually around 5 microvolts. I like to keep it down there in that range of around 5 to 1 or 1 to 5 microvolts. So that's 1 part per millionth of a volt. You know, a 1 volt divided by a million. That's where I like to keep the voltage down. And even a dead battery has more voltage than that. So when I feed it from a high, but I give it a high frequency, and that's very significant. So I do the opposite of everybody else. I do high frequency, low voltage, and everybody else is doing a moderate voltage with low frequency. But I do something else. I won't tell you what I do with it, but I do use a capacitor. And what I realize now, because I use the capacitor in such a novel way, I actually have more than one capacitor in the circuit, depending on the volume, the output I want the circuit to do. If I want an EV level, you know, lots of energy, you know, like 50 kilowatts, then I only need one capacitor in the circuit. And this is the one that I'm referring to. But if I use a modification of the circuit in which I have to put out only a very little, like 50 watts, you know, 1,000 times less than an EV, 1,000 times less than an electric vehicle. For instance, the motor I took out of the ice cream churning machine that I got at a thrift store that was broken, it was missing a part, a hub, a washer or screw or something that would connect the motor with the blade that churned the ice cream. Well, actually, it rotated the barrel, and the churning paddle stays put. But it lacked that part, but everything else about it worked, so I could plug it in and it would run. And I took it out and inspected it, and then I developed my simulations off of that, as well as my prior work simulating the Joseph Newman motor, because the Joseph Newman motor is a shorted motor, but you wouldn't know it because there's no shorting wire. The short is in space. It's implied due to the way he has configured his device and the way I had to simulate it correctly to give over unity. I realized after rearranging the parts to try to simplify the circuit, because I had it really complicated, but it was the same circuit, I just had to simplify its arrangement, and then I realized it's a shorted motor, and so I went from that to develop to the current version of what I'm working, but I don't use LT Spice anymore that I did the Joseph Newman simulation, and I use microcap, which is a little better in the sense that it's more strict, but it also gives me more freedom, so I can have as many coils mutually connected, you know, mutually inducted, mutually coupled, than just 2. Whereas LT Spice, you put in 3 and it says, that's not a transformer, duh, I want more coils. It won't let me put it in. So you can't even put in a center tap variety of a transformer in LT Spice, unless, I don't know, unless there's something I'm missing. Maybe there is. I was trying to do it from scratch. They have different methods, so who knows. Anyway. So where was I? Oh, so the one capacitor that's necessary. So in the small appliance model that puts out 50 watts, I need extra capacitors to regulate the system, to regulate the circuit, to prevent it from collapsing. Because as Eric Dollard has said, you can't produce over unity. You can't synthesize electricity in small quantities. You can only do it at a level comparable to the substation of the utility grid, which I believe is 500 kVA. Now, I don't understand the term kVA, I have to use it because I'm quoting Eric. All I know is that's a lot of electricity. And it's kind of true. It's a whole lot easier. It makes the circuit a lot simpler. So when I have to do a 50,000 watt output for an electric car, I can keep the circuit nice and simple. But when I want to make it for a small kitchen appliance, it becomes a little more complicated because the whole thing wants to stall. And I'll never forget, because I was young when it got burned into my brain, nearly 40 years ago when I read a little pamphlet talking about people's inventions, because we didn't have the internet back then, right? And it was talking about Lee Rogers in Iona, Florida. And he came up with a modification to the internal combustion engine in which he threw out all the components that had to do with the use of gasoline, because he was running his car on compressed air. He had tanks in the back of his station wagon, and he had feed lines that connected to the intake to feed it into the block, the engine block. So he didn't need a carburetor, didn't need a gas tank, and he ran his car on compressed air. And then he developed a methodology by which he had a rotation of 4 air tanks, and while he was filling 1 or 3, I forget the number, he was emptying out the 4th, and he'd go in rotation. When he finished emptying the 4th, then he would rotate. So I guess he was emptying 1 and filling the other 3. But anyway, so he was able to fill them as fast as he drove, provided he did not drive his car below 20 miles per hour. If he went below that, the car would stall because he couldn't produce compressed air fast enough to replenish the tanks that he was using. But above 20 miles per hour, it became a non-stop, I don't want to say perpetual motion, because the definition of perpetual motion is a fiction. It's a lie. It's a I don't know why. I know why they make it up. It's to tell us why over unity it cannot be done, and then they redirect over unity to perpetual motion and give that definition, share it with over unity when it doesn't even hold. Over unity is like a heat pump. It takes less energy to run it than the energy you're getting from the sun to move around to use. So that's a coefficient of performance greater than unity. So that's over unity. That's what over unity means. It doesn't mean perpetual motion machine who's of the first kind, that is defined as being no energy input whatsoever. It's like, God, give me a break. So, where was I? Oh, so many things to cover here. Well, anywho, so what I discovered in listening to Eric was that I literally, depending on how I create the over unity, the way I do it now, though, is I use a capacitor in a very novel way. And that implies the possibility or the probability that I am creating an anchor in the dielectric of that capacitor that is fomenting, shall I say, or spawning, that is spawning the over unity. Well, I know it's spawning the over unity. It's all based on that capacitor, so it has to be coming out of the dielectric, right? And that means it's capacitive reactance. So I have capacitive reactance dominating the inductive reactance of the circuit to such a degree that it locks in. It doesn't just veer into 180-degree phase shift between the current and the voltage. It just goes there right away and locks in and stays there. And then I have the motor, the motor's divided up into the main motor coil, the starter coils, which I use, they become part of the circuit, and then there's the rotor coils. So I have 3 groups of coils. Originally, I was using the rotor coil, I think, exclusively as my source of over unity, but it wasn't that stable. So see, it shows switching to capacitive reactance is a whole lot better. So when I found a way to use a capacitor in a novel way to create a surge, a transient condition that is anything but brief, the word transient is so misleading. except for the fact that the circuit would not last very long. It would fry itself to death, and then in that sense it's transient, so whatever, one way or another. But of course I also learned how to regulate it without mechanical devices such as relays or switches. It's a very easy way, but I won't give it away. You have to read the book. It's amazon.com/author/Vinyasi or payhip.com/Vinyasi. A little cheaper at Payhip, but there's no paperback version there because cost me money at Payhip to sell a paperback version, and I'm not about to cut one. I looked up online what it costs to print your own paperback. It costs a minimum of $500 before you even count how many you're going to print. So forget it. Amazon charges me $3 and change. Oops, I just gave away my cost and for my 30-page paperback. So it's like, okay, I'm sticking with Amazon, even though it's been really hard dealing with them. But they're helpful, you know. They do help out when you're having problems. But now I'm sold on EPUB, the file format EPUB. I've got my Calibre software. I've even got the Kindle Previewer that converts it into Mobi. But I I draft it first in ODT, you know, open, what do they call it? Open Writer? I forget. It's Apache. It's an open source writing. It's not Doc. It's not Word Doc, but I can save it in Word Doc. But it's the default saving is ODT. So I draft it in that, and then I transfer it over to, well, I convert it into EPUB, and then I do all my draft revisioning in the Calibre EPUB ebook EPUB file extension ebook software. And it's really easy because it's just a web page. It's just a bunch of web pages and image files and XML data files. And it's, you know, I've done web pages. I've done programming for websites. So it's, you know, like not out of my field. It's just with something new, you know. And I had to use Amazon software at first because I didn't know what I was doing. But now that I'm getting the hang of things, it's like, you know, I'd rather just do it myself. I just still cannot do the book cover according to Amazon specifications. It's so confusing for a paperback, so I just don't go there. So now I really like sticking with ebook format. It makes it so much easier to deal with it and make changes and improvements. So anywho, so the capacitor in question in the circuit is the source of the surge. I know that just by, you know, you take it out, you put it in, you look at the oscilloscope tracing. Duh, it doesn't take much to figure out where the surge is coming from. But listening to Dollard again, it convinces me what I'm doing is the cap and coil variety of Tesla's magnifying transmitter, but it's not an LMD analog computer. Yet it is an analog computer, and it is LMD. It's just not Eric's. Now Eric said, you know, emailed it to me, and excuse me, a postal mail to me, as well as he's posted on Energetic Forum, that he has knowledge of various varieties of network analogs that he will never share with us, because he just shared, you know, in Borderlands video in the 1980s, just two, you know, the square arrangement of two caps facing off, two coils at 90 degrees facing off each other to make a square arrangement. And you either turn it 90 degrees one way or the other to create a transverse electromagnetic daisy chain or a longitudinal magnetodielectric daisy chain. But that's not all there is. You read Bewley and you find out there's more possibilities. And I used one of those that I didn't get from Bewley. I got it from one of Eric's lectures in one of my earlier developments of a supposedly Pierce Arrow application, Tesla's Pierce Arrow. But that was done in Paul Falstad's simulator, so it was too easy. And that's what made it possible, but I can't get away with it in Microcap or LT Spice, so I can't go there. And that's probably why a friend of mine in Wisconsin failed to replicate that circuit, because it was developed in Paul Falstad's simulator. And he was sorry. He was very hopeful that it would work, but it didn't. I wasn't too surprised. I cautioned him, but he was very enthusiastic and he wanted to give it a try anyway because he had a lot of hope in it. but more power to people who have lots of motivation. But I kind of knew the likelihood would be that it wouldn't work. But microcap is so stringent that I don't have any doubts at all. None. None whatsoever. Let's see. So because I know that this particular capacitor in the circuit, and the only one that's really necessary is, at least for high volumes output circuits, varieties of this circuit, it's the source of the surge, so I can safely say then that it is the analog to Tesla's magnifying transmitter without the Tesla coil. And this, of course, is the variety of Tesla coil, not conventional, but Eric Dollar's version, which is Tesla's version, because the two are two different animals. In fact, I think he's preparing an associate or a partner or a friend is preparing a model, scaled-down model version for the 2019 summer conference in Hayden, Idaho. And the pictures that Aaron Murakami are putting up are very fascinating. It's looking really good. It's about the size of what can fit in the back of a pickup truck. It's somewhat in that scale. Anyway, so it's not that, yet it works. It produces the same result. The result being that you don't anchor the circuit into a ground, such as a common ground or an earth ground, because he had to transmit through the earth. You ground it in counter space, and this is something I didn't understand when he would say it's monopolar. I just thought I was just parroting him, and I didn't understand what it meant. You still have to have two poles, but the grounding pole, the grounding reference for the circuit, in other words, the mathematical pole, so to speak, of the circuit, the reference, is not in space. It's in counter space. It's in this case, in the dielectric material of the capacitor in question that I use. And it's not a big capacitor. I found the best efficiency was to use a capacitor around 10 nanofarads for this particular capacitor that is serving as the anchor to counter space, the grounding reference in counter space for the surge to develop. But then it transmits it, I believe, longitudinally to the rotor, indirectly through the main motor coils, because they're the coils of the greatest voltage. The starter coils are mostly composed of amperage. That's where most of the amperage of the device is coming from, while the starter coils have zero voltage. But the main motor coils have a modicum of voltage, a modicum of current, but a humongous amount of voltage. So they contribute most of the voltage for the rotor, while the starter coils contribute most of the current. And the two blend in the rotor, and then the rotor has the correct balance, because I put a little resistor in the rotor of 1.67 ohms that correctly balances the voltage versus the current for my target, which was the needs of the twin AC motors that are in a RAV4 EV from 2002. Namely, you want the voltage delivered to the twin AC motors around 345 volts RMS. Meanwhile, you want the current during cruising to be around 206 or 210 amps RMS for cruising. That for full throttle acceleration. For cruising, you need the amps to be down at RMS around 50. Yeah, 50 amps RMS. 60 tops. Or, as for needs. See, that's how they developed the hybrid, the Prius. From the 2003 RAV4 EV, the model that came after mine, the model year, they put a test device on the backside of the RAV4 EV. It was a motorcycle gasoline generator. It was a motorcycle engine powering a gasoline-fired, it was a motorcycle gasoline engine rotating a generator that produced 50 amps or 60 maximum. It was rated for 60 maximum, but it was regulated to produce 50 amps RMS, and it would feed through the battery pack of the RAV4 EV from 2003, and then onward go to the twin AC motors. And so if you were cruising on the freeway, not accelerating, on level ground, then that's all the amperage you would need to maintain your cruising speed. And so you could top off the battery pack and not, drain the battery pack, and then use the gasoline in a way so efficient that it was even more efficient than a gasoline engine. So that's when they realized you could get more miles per gallon doing it that way, in that roundabout way, instead of just putting it in gasoline in a gasoline, internal combustion engine, which is less efficient. That's why the Priuses are so popular in hybrids now, because of efficiency. But that's the data. See, I got the data from Alan Coccioni, who, if I'm saying his name right, who is a race car enthusiast. He likes to race electric cars, and so he developed the motor controller for the EV1 that General Motors sold between 1997 and 2003. That's basically a high-fidelity audio system. This is the way he explains it in the movie Who Killed the Electric Car Part 1. But he started two different companies, he started one company, AC Propulsion. I think there's another company, and then there's another website, and that's where this other website, I forget the name of it, is where I got my data from when they were testing out the predecessor to the Toyota Prius, because I needed to know the numbers so as to how to modify my simulation to accommodate those two extreme conditions, cruising on level ground and accelerating up a steep incline. So at least I could satisfy my hunger to know, is it possible in microcap of all places to create a simulation of a circuit, not a moving motor, but it's not much different, but it is a little different because it's not fully tested in a moving motor, but at least the circuitry for a transformer, even if it's not a motorized transformer, at least for a transformer, can it put out the right amount of power? Now, there is a hedge, and a disclaimer, and I better say this. This is not a generator. There is no way that I can see, because I've tried it, that you can bleed off electrical energy to power a load, an electrical load. So this is not a generator. It is because it was derived from my prior work on the Joseph Newman motor, which again is also not a generator. All it produces is mechanical output, so that you can run something else that needs a rotary mechanism of lots of torque. Not speed, but a lot of mechanical rotary torque. And that's what the Joseph Newman motor is good for. Now maybe that's all mine is good for. I don't know. But the point is, it cannot produce electricity, because if you try to use the electrical output, the whole thing goes flat. You lose your resonance. So, but it will serve as a motor, at the very least. I'm hoping a motorized transformer, because all of the energy is, it's because of the fact that it's at -0 power factor, 180-degree phase shift between current and voltage. That's why. Because all the energy is centripetal. See, the laws of thermodynamics assumes that current and voltage waves are in phase, in lockstep phase, so that your power factor is unity, or nearly so. And then the laws of thermodynamics applies, but they do not apply to a negative power factor. In fact, when I was looking up negative power factors, a lot of sources, a lot of people will say it's impossible. You can only use 2 quadrants of the circle of the conceptual model of the rotation of the rotating field of the AC field to qualify power factor. You can't use the other 2 quadrants. Well, then that analogy is flawed, and it shouldn't even be used. The fact is, it's bogus to restrict ourselves to 2 quadrants when all 4 quadrants are possible. It's just a question of whether or not you create a circuit to go to those other 2 quadrants, namely negative power factor. So a negative power factor is possible, but what it means It's no longer centrifugal. It's no longer radiating. It's no longer dissipating. See, the only way we run our appliances is through dissipation, okay? But we have to do the opposite of dissipation. When we charge up a battery, you know, we're dissipating energy from some other source to do so, but from the battery standpoint, we're not dissipating, we're accumulating energy. So at some point or another, we always have to do the opposite to balance everything out. But we won't even talk about negative power factor because we just assume you don't do it. And, well, it's not good for corporate America, but that doesn't mean you can't do it. So when a circuit does that, it becomes a life form, because that's what living creatures do. They accumulate energy. Now, we also expend energy, but we also spend a certain amount of time accumulating energy. So we do both. And our machines, we're programmed, the mind virus, as Eric calls it, we're programmed to believe that machines can only dissipate. They cannot accumulate energy. They're centrifugal. They're radiative. They fully support the laws of thermodynamics. But the converse is also true, the inverse. They can accumulate energy. It becomes centripetal, and thus it cannot be an electrical generator because it can't share it with anything else. The electricity stays totally within the system. It runs it ever so nicely peachy keen, but it cannot have cup overflowing share with others. The electrical part. Now, certainly, it could be possible, I could envision, I suppose, you could make a resistive style heater, possibly, you know, so that you're dissipating heat, but anything other than electricity, you just can't share the electricity. Of course, one of the issues is anytime you dissipate a conversion, now you're dealing with radiation. So can it work? Would you lose resonance? This I don't know. I'm hoping it won't happen, because I'm already lightly loading the device. So why should a heavy load change anything? In fact, John Benini would say in some of his videos that when you have an over-unity circuit situation, you have to have a little light load in there, such as a little neon bulb, to ensure the thing doesn't go wacky on you and blow up in your face or something, or no, to actually turn it on. No, it wasn't to prevent it from blowing up. It was to prevent it from not coming on at all. So he had to lightly load his circuit in order to get it to run at all. That's interesting. Huh. Now, there is another technique for creating a surge other than the use of a novel use of capacitor the way I'm doing it. I just don't use a capacitor. I use it a certain way. But there is another technique, and the one I was referring to, inductive, is in which you lower the mutual induction between the rotor and the other coils down to a value much lower than 10% coupling coefficient. Because a rotor's relationship with the main motor coil of a motor varies as it rotates, but it'll go from a low of like 10% up to a high of 50%, and it'll go up and down and up and down and up and down. But if you lower it below 10% and keep it no higher than 8 parts per thousand and no lower than 5 parts per thousand, that narrow window is how I used to create the over-unity event in the entire circuit, was to have that mutual coupling relationship between the main motor coils and the rotor coil. Now, I never included the starter coils because the starter coils are just 2 turns of very stout wire, and so I don't hold them to be entirely very strong magnetic influence. It's there, but it's nothing to get in the way of anything else. But so I would always focus on the main motor coil, you know, many turns of thinner wire, creating all of the juice. Well, creating all of the magnetic field. Because that's the way, you know, an AC motor is set up. That's the main motor coils are providing most of the magnetic field. The starter coils are just there to help the rotation of the rotor in the direction you want it to go, and not just wiggle back and forth. So that's the way I used to do it. And like I say, it's kind of iffy. It's unstable. It's not a very good method, but it can work. But it is an important point here, and that is increasing the isolation, the magnetic isolation between the rotor and the main motor coils. Now, what is isolation? Isn't that capacitive by its very nature? It's certainly not inductive, because you're reducing the mutual coupling. You're not increasing it. And the minute you start to reduce, for instance, the mutual coupling between each winding on a coil by spacing out the windings to create a true Tesla coil, you know, you have a wooden armature, let's say, with grooves on it, slots, and you rotate and you wind the coil just one layer, one turn per set of slots as you go around your armature. That's a true Tesla coil because of the increased capacitance between each turn of the winding. Well, here I'm doing something similar, or did something similar in the prior version of this circuit, in which I reduced the mutual coupling between the rotor and the main motor coil to the ideal value of 8 parts per thousand. That's a pretty small induction, and that means there's a lot of room for capacitance, because now we've got these two coils that are extremely loosely coupled with a lack of communication between them for dominating their relationship. And I can't help but think that that's capacitive right off the top of my head. You know, capacitance and inductance, and I say this for a reason. When I looked, one of the things I got out of working in Paul Falstad's simulator was I looked into the Java code to look at the mathematical formulas, because I hated math in school the way they were teaching it, so I never took electrical engineering, so I'm not an electrical engineer. Yet, I can let the simulator do all the work for me, and then from time to time I can go in there to make changes, you know, improvements, and take out things that don't belong, like regulators, caps to prevent transistors or diodes from having transient surges. I think Paul Falstad put in an arbitrary cap of 1,000 amps. And I thought, this is ridiculous. Why is this here? Because he thought it was weird, so I took it out. That's the only time I modified the math initially. But eventually I had to modify it again some more because there was no equivalent series resistance in his caps or coils. And that helps to make the simulation more realistic. So I went in there and I saw the reciprocal relationship between how his capacitors computed an equivalent current source from their voltage input to have an equivalent current source output, so they would become a current source, because that was part of his modeling technique, was to have that style of equations in there. He had it for the caps and he had it for the coils, but they were reciprocally opposite. In other words, the denominator of one became the numerator of the other and vice versa. And so I knew I needed to put the equivalent series resistance of a certain amount of ohms somewhere in there. And it was just a question of where. And then when I looked at those two different varieties of each other, I realized that the capacitor, if you start putting in a resistance, a value of resistance, into the formula for current source of the mathematical model for a capacitor, you're literally creating negative resistance. And if you put the resistor in the coil mathematical model for a current source, it becomes positive resistance. So it became harder for me to create over unity from the standpoint of the coils, but it made it easier from the standpoint of the capacitors. And when they work together, the coils actually help the situation. You know, they work together. It's amazing the way caps and coils work together to create a synergy, especially when you start putting in equivalent series resistance. It just starts to take off. It makes certain circuits harder to produce. It all depends on the design of the circuit. So a lot of my circuits just disappeared. They just couldn't work anymore. But certain other types of circuits got a boost and worked even better. So it's really uncanny the way things can work out sometimes. But that's when I learned about the nature of what was the point? Well, the math. Oh yes, the property of the dielectric. That's why I say it's easier working with a capacitor to create over unity than it is with an inductor, because it's already from the get-go any kind of resistance, equivalent series resistance in a capacitor is already in your favor to create over unity, because you've got negative resistance built in. It becomes a negative resistor. It's already automatic. What else? So it's not. I shouldn't be surprised then that I'm using a capacitor to create a surge, to anchor the device. Its grounding reference. I'm assuming it's the grounded reference, because it's the only reason for the surge to occur in my circuit is the dielectric of a single capacitor used in a novel way. I don't understand why the novel way works, the discrete mechanics. I just know it works. I get the results. And it is different. It's not the way you normally hook up a capacitor in a motor circuit, a motor wiring scheme. It's not your usual way. I can give that much hint away. Hint. I priced the books a little higher because I value them, but also because I don't want curiosity seekers. And, I don't want somebody who's just curious to take a look. I want somebody slightly more serious, slightly more motivated than just merely curious. I could charge $1,000. Well, no, not really. If it's Kindle, I can go up to $200 and something. I forget what the limit is on paperback for 30 pages. But, I could charge a whole lot more, and in the beginning I did, because I didn't know what to do. I went high, I went low, and then I realized slightly above the lowest figure. If $9 for the paperback and 99 cents for the Kindle is the lowest, $9 and change, versus 99 cents, I can raise it a little bit. Make $45 for the paperback and $35 on Amazon for the Kindle. These are the circuit books, not the theory book. The theory book, I cut the price in half. The theory book is up to 21 pages. So I added a lot of material yesterday, because it was originally down to 12 pages. But I managed to get it up to 21. Still not big enough to make a paperback version out of it, but I don't think I ever will, because it's just more convenient to keep it as a Kindle with, as an ebook with a lot of links in it, because it's a lot of links. So that's what I think is going on in my circuit. The capacitor is acting as a grounded reference in counter space, sending longitudinal waves via the main motor coil to the rotor. So the main motor coil is acting as a broadcast device, a broadcast aerial, because it's a coupling between the two, and it's not even a strong coupling. It's 10%. A loose coupling between the rotor and the main motor coil. So the rotor coil is the receiving coil, and the main motor coil is the broadcast coil. Yet, you would think, well, that means it must be broadcasting transverse electromagnetic waves. But the fact that it originated from a capacitor makes me wonder, is it a blend, But the fact that it's -0 power factor means there can't be any, not even a scant amount of inductive reactance going on. But that's inductive reactance. What about the non-reactance of an inductor? That's still pretty strong. So it shows that there really are 4 factors to electricity. The positive and negative factor of spatial waves, the transverse electromagnetic waves, and the positive negative counterspatial waves or longitudinal waves of counterspace. If I say that right. And all 4 factors figure in. And you have to look at all 4. And so when Eric puts up on the board the equation for the telegraph equation of Oliver Heaviside, when I saw that, I realized right away that's not the same equation Wikipedia is claiming the Oliver Heaviside telegraph equation is. They left out 3 out of the 4 parts. They left out the imaginary, unless they're just assuming you know better not to think that it's not included. But they left out the let's see, what would that be? Well, right, the longitudinal component. So you have the transverse component, the longitudinal component, and then you have the real of each and the imaginary portion of each. And they left out the longitudinal. So it's like, hello, But this is what happens when we have truth by way of democracy. Let's vote on it. Them and Stack Exchange. How can you know what the truth is if you just vote on it? That doesn't work. Oh well, whatever. It's life as we know it in today's world. That's the peon aspect of the corporate world. All the little peons that keep the corporate world going. We vote on it. We vote on what we're going to do, what we're going to believe in. I guess I've said everything I need to say. I had to get it off my chest. I spent all day working yesterday, not paying attention to much else, because I really wanted to add more material to my little ebook. And I can't be more happier about Calibre. It's open source, free. Well, I don't know about open source, but it's free software. You don't have to pay for it, and you can write your own ebooks in Calibre. And if you're not scared off by HTML code, you can have a gas, have a lot of fun. And there's so many different outlets for ebooks. Barnes & Noble, I have to tell you, I tried Barnes & Noble, and I'm still waiting for them to review my submission. And that was like at least a week ago. How long does it take, So I've given up on them. I thought Barnes & Noble would be a good alternative to Amazon, but nope, I don't think so. But PayHip is very good, and there are many others. I don't need to complicate my life. 2 is enough. Amazon and PayHip, and I'm happy. PayHip, they make it so easier, because they don't bother to review, You just do it, you make changes, and it's immediate. And, it's Amazon, my God, everything has to go through review, and it's I don't know, whatever. But I have to say, though, those are the only books I've sold. I haven't sold any on PayHip, even though it's cheaper. I don't promote PayHip, but then I don't think they promote themselves as much either. I think, YouTube has this nice cozy relationship with Google, so just about everything put on YouTube you can find it when you Google. And I think it's the same thing between Amazon and Google. They have a nice cozy relationship. But I don't think PayHip gets the same status on Google. So I have sold a few copies. They're all Kindle. One paperback. That's right. And 2 Kindle, I think it was. So I've sold 3 books. All the English and the Circuit. The theory is a little new. The Spanish, I've had problems with the paperback cover. Hopefully that'll be rectified one of these days, and then I'll be able to put the paperback Spanish version of my Circuit book back up available, but at the moment it's not available. But the Kindle, the ebook Spanish variety on Amazon is available. It's always been available from its inception. And of course the English and the paperback Circuit book on Amazon is available. What else? Well, I think that's everything. I'm excited, obviously, or else I wouldn't be talking so much. It's a lot of fun. And I keep learning, Eric Dollard is a wealth of information. And if it wasn't for him, I wouldn't be able to do anything. I mean, surely I have inner guidance, and inner resources. I don't think I was an electrical engineer when I taught Nikola Tesla in a past life. I think I was a physicist, probably teaching him physics or something. Because that's what bothers me the most. And I'm more a theoretician, have you noticed, than I am an electrical engineer. I'm more prone to want to think about and understand something than actually go and build it. Although I needed the simulator to bring, to help me understand things, but still, I don't really, building something is a whole technical expertise of its own. You know, not just knowing how to work with your tools, but the materials. You know, John Bedini knew a lot about substances. He studied geology. So it's a whole other area. And I've been focusing mainly on theory. So I think that's probably the kind of teacher that I was when I was teaching Tesla back in the day before he became Tesla. But now that he's already been Tesla and he's come back already as somebody else, I have that, because, it's all karma. The teacher taught the student, and now the student guides the teacher. So it's karmic payback time. So I have that going for me, as well as whatever gifts I was born with, intuitive gifts. But the rest I gotta train myself on the simulator, and then look up what Eric Dollard has to say, because it takes a lot of finesse to understand this thing to any degree. I have to say, though, and I better say it out loud, what I've said, the last addition to my theory book I made last night, a little section, I have to give up my nomenclature of magnetomotive force and electromotive force. I was trying to be convenient, I was trying to marry. I was trying to bring together the schism between Eric Dollard and physics, and I failed, because it's impossible. I came to the conclusion after listening to Eric that the physicists lie in more ways than one, and the one that bothered me, what I learned last night, is that there's no such thing as mass. It does not exist. And there's no such thing as matter. They like to play this game, just like our government likes to play the game. Are there aliens? Yes, there are. No, they're not. And then they deny both in their bid to try to explain away UFOs, while UFOs are actually man-made. So they cook up two different versions of who makes them if not us. Oh, the aliens do, the aliens don't. Well, that takes care of that, and end of argument. No, neither one of those has any grounds for debate. It's all us. The Nazis got it from Tesla, and we got it from the Nazis, and now everybody has it. Any major world power has it. But what was the point? I know there's a pint of a point. Oh, where was I going with that? My short-term memory. Oh, physics, matter. So, we know this game that physicists play. Oh, is it a particle? Is it a wave? Oh, the uncertainty principle, we can't tell. I can tell you right now, there's no uncertainty. Didn't Einstein say God does not play with dice? Come on now. Even Einstein got at least something right. There's no particle because there's no mass. There's no matter. Everything is just energy and nothing but energy. And it just happens to be electrical. The nuclear thing, I don't know. Maybe it's true, but it certainly doesn't have any mass. And it was the way Eric Dollard described how how dielectric lines of force unite what they do with their two endpoints. I just assumed, because prior to last night I didn't really remember, not that I haven't listened to this same recording before of Eric, but I didn't remember what he said, so I just assumed that dielectric lines of force terminate on the nucleus of an atom, two different atoms, and that multiple lines of force will emanate out of and go into the nucleus of an atom to create a neural network, so to speak, of an electrostatic voltage-oriented or dielectric-oriented gradient to the universe, in which everything is communicating with everything else simultaneously. And so the dielectric lines of force are a means of communication between objects, and the magnetism, the toroidal magnetism circulating around each point in space, is what gives us the atom and gives us gravity, atom, mass, all of that stuff. Well, it turns out, according to Eric, the dielectric lines of force terminate on protons at one end of each dielectric line of force and electron at the other. And the electrons and the protons themselves are not objects. They're just the terminus of the two endpoints of a dielectric line of force. And he says they're discrete, these lines of force, because their unit is the quanta, and there's no, that's the indivisible, I guess, in the material viewpoint of physics, is the quanta. But the lines of force are discrete. They're not wishy-washy. They don't come in different sizes. They're just one size, and so there's a discrete number of them based on the strength, the total strength of the dielectric between 2 points. Well, when he said that, and that the proton and the electron doesn't exist, it's just the terminus of the dielectric end of force, dielectric line of force, that means that the mass isn't there, and that leaves all the mass of the physicist's theory about matter to be burdened on the backside of the neutron. And that's when the whole thing collapsed in my face. I realized that's not going to work, because the proton is in the center along with the neutron. So how can that be? It's just, the whole thing started to it became an escalatory trend. The whole thing just collapsed in my face. So I realized that. And then I also was watching him work on the whiteboard during the video. Origins of history of the theory of the history of electrical theory video that Aaron Murakami put up. When he was working on the whiteboard, he was deriving the electromotive force from the magnetism divided by time as an analog to a similar hyperbolic function in which mass divided by time will result in what happens when you apply the brakes to your car, and your car is trying to come to a dead stop, but it doesn't come to a dead stop right away. But in theory it could, if there were no dielectric lines of force, if you could turn them off immediately. And this is why I think my device is the analog to Tesla's magnifying transmitter, because Eric was saying that he believes that's the way UFOs work. They are monopolar, longitudinal, and they are completely in control of the dielectric field surrounding them, so that they can turn it off at will, and then you don't get the screech effect, the time lag between applying your brakes and how long does it take for you to burn rubber skidding along the road to come to a complete stop. Well, in the case of a UFO, no time at all, because they control inertia. Well, okay, controlling inertia is nice, but again, that's relying on the physicist's terminology, which doesn't really tell us what's going on, something tangible that we can measure. But when you say dielectric lines of force, oh, you can measure that. And so that's how you control inertia. And that's how you create a monopolar electrical device grounded in counterspace. That's it. That's the way to explain it. So watching that video over again really did it for me, because I guess I was in better shape to appreciate some of the things that he says, instead of it just going past me, and I'm going, duh, At least I was able to understand a little bit more than the last time I watched the video. So I can appreciate my circuit better. It's going to take me a lifetime to appreciate it. I just bumbled my way through this. 3 years on the simulator doesn't mean I know anything. It just means I have a knack, and a belief, and a motivation, and lots of time. But it doesn't mean I understand what I'm doing. So, but gradually, from Eric and other sources, sometimes Wikipedia, God knows, sometimes they're useful. Then gradually I get to understand the significance of what I've managed to do, because otherwise I don't know. I don't have the slightest clue. It's like, I just don't know. I just do it and it works. Doesn't work, I move on to something else. I take the Edison approach, the approach by way of exhaustion, in which not only do you exhaust all possibilities, but you also exhaust yourself in pursuit of all possibilities, because it's only when you're fully exhausted and you're convinced you've tried everything and you're still failing, only then will you find the one, if you bother to take the extra step, you will find the one that actually works. Trust me, that's the way it's exactly the way it worked for Edison when he was looking for how to create a better light bulb, and it's after thousands of different substances. Although the story you hear on the internet is usually tungsten, but initially the success story was not tungsten. I think tungsten was just an improvement. The first success he had was carbon filaments that he got out of bamboo. He would cook them to the point of becoming like charcoal, and they would glow and not burn up inside his bulb, unlike all the other methods or substances that he tried. Thousands of substances, him and his associates. So that was the first success. I think tungsten came later, if that, tungsten filament as an improvement. In any case, that's the approach I take, because I have no idea what I'm doing. When I do it on the simulator, I don't know why it works. But now that I've had a chance to, think about it, I get a better appreciation, and so I'm thinking, this is not bad. It's not a bad circuit. Negative power factor of 0. Negative 0 power factor. That's a heady statement. Any electrical engineer would know what I'm saying. Probably tell me I'm foo-foo, but there's a guy on the internet who's an electrical engineer. He's a member of the IEEE, and he says differently. He says there is such an animal called negative power factor. He didn't talk about negative 0 power factor. I guess he was assuming it would be something shy of 180-degree phase shift between current and voltage, but he does acknowledge it exists. And he defined it. He defined it as the predominance of capacitive reactance. So there you go.